Thank you very much for joining me this early morning. Not only myself needed to wake up as early. So my name is Sergey Ryabov, and I work at Facebook in London in native UI frameworks team. And one of the products that we're building is Litho, declarative UI framework for Android. Can you please raise up hands who knows already what is Litho? Not many people, so gladly I put some introduction slides as well. So what is Litho? Litho is a declarative API, provides declarative API for building your UIs for Android. It has an ability to asynchronously laying out your UI, something that Android framework doesn't provide you. Also, with Litho, you end up with flatter view hierarchies that's known as a not very good idea to make very deep hierarchies in Android. And also, Litho is capable to recycle not only complete view items as a recycler view, but even smaller widgets. So how does UI in Litho look like? Something like that. We need to declare spec file in our project. It will, the class itself will be annotated with a special annotation layout spec. So the main method in this layout spec is onCreateLayout. That's the method that is responsible for really building your layout. And this method should get component context as the first parameter always, and always return a component. Component is like the basic building block of Litho UI. Litho component can have some input parameters. They should be marked as props. That's something that will change the look and feel of our UI. And with these input parameters, Litho is building UI using flexbox primitives. One of these is column. If you're not familiar with flexbox, I will point out to some playground where you can try it out. But this column is basically like a vertical linear layout. So in this column, you will have two text fields that will show our props, our input parameters. And how this UI can be used in our application, in our usual Android application. Quite simple. We will just create our component context that needs to be passed and create Litho view. That will be the view that will be responsible for rendering our components to usual Android canvas. So here we create component with this props passed down, title and subtitle. You can notice that name is slightly different from spec that we declared here. That's the convention. So spec is basically something immutable. So you just provide declaration of your UI, but the component that itself will be rendered on UI will be generated later. And the class name will be without this suffix spec. Also, you may use composition to build your UIs. So that's an example how you can trigger laying out in Android view using this component. But you can also use this inside another layout, Litho layout. So that's a list item with image view and two texts. And here you can see that we create row. That's like a horizontal linear layout, also flexbox primitive built in Litho. And we pass two children. One is image, and one is our previously declared component that also requires passing this title and subtitle from the parent component. That's kind of the thing how Litho favors composition over inheritance, and to just add up some functionality, you don't need to extend, for example, your base view and then add something inside. You need to just declare another component, and you can compose them one into another. And this won't actually result into deeper view hierarchies. Not to be talking about some magic, I would like to also show you how this works under the hood. for a little bit. So there are 3 major steps that we perform to move this layout that we declared in the spec to UI. First of all, we need to create our internal representation of our tree structure for these components that we declared in the spec. Then we need to construct layout state out of this internal tree representation. That basically will be list of final items that will be rendered in the screen. And we need to mount this layout state in the screen, like on Android canvas, basically. So how does that work? We have this list item with image spec that I showed you before. And the main thing here is our layout, of course, like this row with 2 children. So to create layout component, we call onCreateLayout on the component. And the insides of onCreateLayout will be building our tree. So like when we trigger onCreateLayout for a specific component, this will mark the root node of our tree. So like root node of our tree will be responsible for, will represent this list item with image component. But this component actually doesn't create anything in the tree because itself is a root, is a row. And this row will also correspond to this node. That's actually the primitive that will create the actual node. Going down, we will see first child, image. Image will end up being leaf node here. Then list item component, something that we declared before. So we need to create another node for this child component, but we then recursively just call onCreateLayout on this component, go inside, and we see that it's column. So column will also be tied with this node. And then 2 children, 1 text and 2nd text. So as you can see, here we have slightly similar structure as with our Android views, something that represents our UI tree structure. And after that, we need to create the actual output to UI. So the actual output, this layout state, is created like in 2 steps, I would say. First of all, we need to measure this tree. So we are measuring with Yoga layout library, something that is built in Facebook as well, and it's cross-platform. It is powering not only Litho, but also React Native and a bunch of like web frameworks and Android and iOS frameworks, iOS component kit framework. So we delegate with this measurement to Yoga, and after that we get all the absolute position and bounds assigned to each node. Each node will know where in the screen it should position itself. But after that, we will trigger the traversal, deep traversal of this tree and pick just only these nodes that will end up reflected in UI. So for example, here we can see that row actually is not drawn anywhere. So we just needed this for laying out. So we're skipping that. Image will be drawn actually in the screen. So we add this image to our list. And then column. Column also was needed only for laying out our items. So we just skip this. And text will end up in this collection as well. So finally, we can see that our tree structure was transferred to only 3 items that will be drawn on the screen. And what is more important, all these 3 items will actually not be views, but they will be simple drawables, something very lightweight and very lightweight in terms of performance and in terms of memory consumption as well. So we in Litho fall back to drawables wherever we can if something special is not happening. So that will comprise our layout states, and after this collection step, we need to mount this layout state to our UI. And that's actually the only step in creating our UI that should be performed on UI every time, because we are interacting with Android framework itself, and you know it doesn't allow you to do anything with UI in the background. But due to being able to lay out and measure our views in the background, we can do that like simultaneously, pre-calculate our layout, especially in recycler view when we have like several items being shown on the screen at the same time, especially when scrolling. So we saw layout spec. We saw how we can declare this like composition of our simpler UI blocks. But what are these leaf nodes actually? So that's not something kind of magical or tricky or built-in as column or row flexbox primitives. That's actually mount specs. That's another primitive of Litho. Mount specs represent leaf nodes in our layout structure. Mount spec has also several important annotations that you need to remember. It's mount spec. First of all, you need to declare your class as a mount spec to be handled by the annotation processor. Method that is responsible for creating actual content that will be mounted to the screen is onCreateMountContent. And as I told you, we support drawables, and also we support views. So this method should return either drawable or view. And second most important method is onMount, that is responsible for actually mounting this content to the screen. Like here you can see we can refer to the same props as in layout specs, something that is our input parameter for Litho. And here in this example, we are just creating gradient drawable, and we actually assign gradient colors to this drawable in onMount. What is tricky about mount specs, and something I guess like you should take into account, is this couple of parameters, pool size and is pure renderer. So pool size is responsible for declaring the size of the pool from which we are getting this mount specs. So for example, when we don't need some widget, we also recycle it. Kind of a similar as a recycler view, but we are able to do that to single widgets. And if, for example, you know that your custom mount spec that you're writing will be used everywhere in the application, it may be like tens of these mount specs on the screen at the same time, you obviously will want to increase this default pool size. That's the parameter in this annotation that is responsible for that. And second thing is pure renderer. It's a flag that tells the Litho that these mount specs always will bring the same output if your props didn't change. So like the same input will bring to the UI the same outputs of the of this component. That is actually quite important assumption, because we will be able to reuse something that was created on the previous steps, for example. As mount specs can also represent views on the canvas, and not all views can be like pure renderers. They sometimes have their own state that may be like very tricky to reason about. Maybe it can be changed outside of the parameters that you're actually putting to this view. It's not always true. So like this parameter is false by default, but if you know for sure that your UI output won't change, for example, if you have image and you will pass the same image to the mount spec, it always will be rendered the same. You will set true to this parameter. That's an example how images are actually declared in Litho itself. So that's something that is provided to you with the framework bundle, but it's like a usual mount spec, nothing magical. And you can see that images are set to use pool of 30 items, because you can have lots of images, especially like with scrolling lists, and that's a pure render function. And using this pure render parameter, we can provide several optimizations to the way how we draw this components to the screen. First of all, we have such optimization that is called diffing, layout and mount diffing. We are able to reuse measurements from the previous steps and actually lay out outputs, these actual items that will be drawn on the screen from the previous pass, if our mount spec is pure renderer. Let's see an example. So on the left, we have internal node tree, internal representation that was built for the updated UI. And on the right, we have this so-called diff tree, some structure that we bookkeep in between layouts. And this bookkeeping structure has all the measurements for mount specs and all the layout outputs for the mount specs. And when we create new internal tree for new component, we just traverse these trees, both of them simultaneously, and see if our props for mount specs didn't change. We just reuse these measurements and layout outputs without creating new ones. So for example, here you can see that if our leaf nodes didn't change, we just reuse measurements. And when creating layout state, we will just use something that was already handled by the framework before. Another kind of optimization that is very useful, I would say, is incremental mount. Let's see an example. Here is the list of items, something that looks very similar to Facebook feed, for example. We are scrolling this list of items, and what we will see here, we'll see, like with usual recycler view, what we will see? We'll see that the item that is about to be shown on the screen will be inflated and laid out as a whole piece, big, potentially big list item, and if it is really big, it may result in skipping frames because we won't, for example, fit in 16 milliseconds. In Litho, we are able not to mount the whole list item in one go, but do this step by step. So when we are scrolling and this image shows from the bottom of the screen, this image is mounted to the screen. When our text views are coming to the bottom of the screen, they are mounted incrementally. And then big image comes to be shown, it will be mounted as well, like only this image alone. That makes it possible to distribute the performance impact of mounting through several frames. So we don't need to fit all the mount process to 16 milliseconds. We just do this gradually while user is scrolling. So keeping in mind these optimizations and how things work under the hood, there are some gotchas that you may take away from this talk at this point of time. So you should use isPure renderer, and supported function should update, that will tell you whether the component is updated or not, to reuse previous layout results, not to spare time on that. Also, you can tweak your mount pools if you know that your mount specs will be heavily used onto the screen. Next topic I would like to talk is managing state. Obviously, not everything can be rendered just with input parameters and some output components. We need to keep track of some state, for example. Let's see the classic example of counter. We just push the button plus and counter increments. How we can implement that in Litho? We will use this state parameter that is marked off with the specific annotation, state, that will be present only inside this component. So this won't end up being a builder method for like a props, for example. And here we just put this count as a first text content, and second text is plus. For updating this state, we need to declare onUpdateState function that will just increment the value. Take previous value, increments, and sets it again. And we need to bundle this with event handler to react on clicks. Event handler are declared with onEvent annotation. Last step is to wire up this event handler with the plus button, and basically that's it. But one thing to notice is that we are not passing actual state as a parameter here. You can see that the only parameter that is passed is this C, component context, is because state is handled inside the framework itself. So one thing to notice is that we have the same name for the state update method as we declared it, even though we don't call this specific method on update state that is annotated with annotation. But we also have second one, increment sync. Thing here is that we, by default, do state updates in the background thread. We do this asynchronously, not to block UI thread if it's doing something. And if you really know that you need to do this quick state update right here, right now, you can call increment sync. One thing to keep in mind is that changing state always recreates layout. So the whole process that I explained in the first part will be recreated. We'll build a tree, we'll measure all this stuff, blah, blah, blah. So you need to understand that and keep that in mind. But you can optimize this. First of all, we can stumble upon this problem if we have, for example, two state updates. Let's say we want to change color of something and name of something. Let's say that's our fruit, banana, in the fridge. So if we want to change color and name, we can do two update state methods and call them sequentially. First update blue, color to blue, and then name to plum. And as I told you, these state updates will reflect UI. So first state update will trigger updating UI. Second state update will trigger updating UI. The most crucial thing here is, of course, that our banana will first become blue and then become actually a plum. And probably I would not eat that banana. But the less noticeable thing is that we actually will have performance impact of that. So that's a stack trace, sys trace of update state. And you can see that we have two state updates, two tree recreations adjacent to each other. And that's the outcome of calling two state update methods. To mitigate that, we just need to bundle up these updates in the same method. So if you know that quite often you will be updating several states at the same time, you will just put them as several parameters in one state update method. So for example, here we take color and name and update them at the same time, and then call this change fruit method. That will result in something like that, and this picture shows us clearly that we have only one state update, only one tree recreation is triggered. Here you may ask that probably not every state update should be reflected in UI. And if I would like to just do some bookkeeping or something like maybe turn up flag for logging or performance measurements, you would not like to recreate UI if it doesn't actually do anything with UI. For that, we actually have a way to skip these updates. We have a thing that's called lazy state updates, and if you know that this state can be updated lazily, you may mark the annotation with can update lazily parameter, and then use it in your code. So here we are adding step state for the counter example, where we basically enter some value in edit text and increment not by one, but this step value. We don't need to relay out and redraw our UI because it is managed by edit text itself. So we just will keep that in mind, but not trigger layout here. If we have can update lazily flag triggered, like set up, we will end up generating one more method aside of those manually declared on update states, and this will be called lazy update step with the lazy update prefix. This will really change the value. This changed value will be available, for example, for your on-event callbacks, but this won't trigger relayout. And actual change of the backend value will happen at the next relayout. Another way to use state, as we noticed inside Facebook as well, people want to just keep some heavy computations saved for time being. So like you know that you need to initialize some third-party dependency, and you do this calculation, keep it in the state, and then reuse it, like never touching state again. We ended up doing special API for that because that will just like bring you clear intention of what this is doing, and this will definitely be dependent on the some input props and states, and this will be calculated beforehand. So we have this annotation on calculate cached value that will mark the method responsible for doing heavy computation, and it should have parameter of the parameter name for onCreate layout. So here you can see that heavy config is the same string. It is basically equals the name of the parameter. And the parameter itself should be marked as cached value, not state, not props, but cached value. You also don't pass this from the outside. It is managed inside the component. Several gotchas that you may take out from state management is that you should batch your state updates if you know that they will be performed simultaneously. You should use lazy state updates for bookkeeping and other stuff that is not reflected in UI immediately. And for heavy lifting, please use cache values that will be managed for you quite cheaply. Animations. Very often people ask, like, okay, we have this declarative API, but what about animations? Can we do all the fancy stuff that Vue framework provides us, Android Vue framework provides us? Maybe not all the fancy stuff, but we have animation API, and let's see how does that look. So here we can see onCreate layout with 2 buttons, basically, with 1 button, I mean, sorry. When you click at this button, we depend on the state, first of all. So state will tell us whether we should align this button to the left or to the right. And when we click this button, we actually change this state. This button will run away from us. To actually declare animation of running away, so like smoothly moving this button to the right or to the left, we will need to assign transition keys to components that we need to animate. Actually, the same as transition names in Android framework animations. So here we assign transition key button, and we will create special method called onCreateTransition, which will be responsible for creating animations. So here we are passing the same transition key button, basically declaring that this transition will be responsible for animating these transition keys, components with these transition keys. And we just say that observe property X. If this X changed, animate me. This method returns transition, and it will be called on every onCreate layout. And here is a tricky question. Sometimes you will have another on event handlers, you will have another interaction with your UI. In not every time your state will change. Obviously, when you're just looking at the X property, when X property didn't change, you won't animate anything. But we also have something like all layout transition. It is something similar to animate layout changes in linear layout, for example, when you just like set true in XML and framework tries to animate anything that changed. We do the same here. If anything changed between 2 UI states, we just animate this automatically. And here you may imagine that this requires some action to gather all the changes and represent this as transitions. And probably you don't want to do this on every recreation of UI if you know beforehand that nothing that is responsible for animation changed. That is important because onCreateTransition, as I told you, is called for every onCreate layout. And you would like something more granular to take care of animation. And we actually have a way to do that. we support diffs of our props and states. So if you want to check out how to react on this specific change, what transition to provide, or maybe none, you can just provide diff of some prop or diff of the state, which has previous and next values, and you can compare them in this method and return specific transition. Or you can return null, and then no transition will be collected. That will spare your resources when doing updates of the UI. Here, we can track changes both for props and for states. But if you know that you are changing only the state here, and you want to reflect state update with some animation, you can use another way. You can update on update state method with another parameter, with another annotation, on update state with transition. Then this method will require you to return transition, and depending on the previous and next value of the state, you will decide how to animate this. Here, for example, as our align to end is a state, we're changing this, and we decide like that we need to animate property X here because it changed. Some gotchas for animations is that please use diffs for checking whether you need to animate stuff or not. And if you are updating state, you can use on update state with transition for animating state changes. One important thing when introducing Litho to people is, okay, that looks pretty neat, and we can use that. But we have quite a big chunk of UI already. Do we need to rewrite this all in one step? Like, that's quite tricky and requires you a lot of work. Actually not. You can migrate your screens not like per screen basis, but per component basis. You can do that step by step because we have an ability to interop between views. So complex UI parts can be actually represented with Litho components. And in the screen, in your XML layout, at that specific place, you can just use Litho view in XML and find it by ID, and then put Litho component there. It will be rendered by Litho. Another direction of interop is using views in Litho. So for example, if you have something very heavy and tricky, custom view that you implemented before, a video component, for example, that has all the state management inside, updating params, so like streaming, probably support streaming. You don't want to write second version of that by hand using Litho components. You can reuse. You can just wrap this view in the mount spec, as we did with gradient drawable before. You will do almost the same thing, but you will return your video view from the onCreateMount content method. And you can use this in Litho hierarchy. That's actually something that is not only important for your custom views that are maybe heavy, maybe they are used everywhere in the application, but for something that we are not able to recreate, like web view, map view, and some other complex examples. So with Litho, you can use benefits from both worlds and migrate gradually if you want to. And also, as a last thing, I would like to mention some advanced configurations that are available in the framework. So as you saw in the first example, at the very first example, we were just creating Litho view and providing component. But actually, we have an API for more granular tweaks. We have component tree and component tree builder, where you can pass some parameters. I would like to highlight two most important and most useful for you right now. One of them is layout handler. It's handler where layout process is performed. Like, as you remember, it is performed on the background by default. And here it may be important, for example, if you are using Litho on two adjacent screens. And at the first screen, you're laying out quite big list of items. Litho is made the made the optimization to pre-calculate several items higher than your viewport and lower than your viewport. That is really nice for scrolling, but this may hit you back when you're navigating very quickly from the screen. For example, you just opened the list and then instantly clicked on the item. Before you will be able to lay out second screen, you will need to wait for all the items of this list be laid out. Not all total, but like some on the top of the viewport and some on the on the bottom of the viewport. So to mitigate that, you may provide your custom layout handler for this second screen, for example, and this will start laying out as soon as your activity will be available. And second thing is reconciliation, something that allows us to spare even more resources when recreating almost unchanged layouts. At the beginning of the talk, I spoke about diffing. Diffing is quite simple optimization. It's basically for like reusing mount spec results. But here, if you will use reconciliation, you will not recreate the whole internal node at all. If some subtrees didn't change, we will reuse the whole internal node subtree from the previous pass with the measurements and layout outputs, with everything. So that will speed up your layout process even further. This is an experimental API, so be careful with that. And also, one of the important questions here is, what can I do if something doesn't work? Also, what can I do if I don't know Flexbox layouts? And what can I do because you don't have layout preview? I will tell you a couple of tools to handle that. So first of all, our layout engine is Yoga, and you may want to practice some yoga jiu-jitsu with Yoga Playground. If you don't know what all these parameters for column and row mean, like what is flex direction, what is flex wrap, what is align and justify, you can use this very interactively in the web and just see how your UI will be composed here. Second thing is something that substitutes your layout preview plugin. It's Flipper. Flipper with layout plugin. It's a standalone tool that is built also in Facebook. Probably some of you know Stetho. Can you show hands who use Stetho? So Stetho is a command line thing. Well, it's a plugin that outputs something in the command line and also bins to Chrome DevTools. And Flipper is basically like a next vision of that development tool. It's a standalone thing with with its own UI and being able to support not only Android but iOS as well. And one of the core features of Flipper is being able to see the actual layout of your screen, not only speaking about views but about Litho components as well. So like here you can see how Flipper shows the layout structure of the screen. And one other nice thing is that Flipper supports in-place editing of your parameters. So you can tweak your UI, like change padding, change margin, change flexbox options to like lay out your views, and it will be reflected right here, right now on your mobile phone screen. That's very useful. You don't need to recompile to tweak your UI and see how it will look like after that. One more thing is error in the slide. So one more thing is actually we are building IntelliJ plugin for Litho that will help you to create all these tricky annotated methods with some templates and wizards. So one of the things we have provided a Litho wizard for mount specs and layout specs, and also we can generate component lifecycle methods for you for not like remembering the number and ordering of the params. That's something that is heavily beta, And if you want to use that, you can just go to our open source repository and build this plugin by yourself and just add it in IntelliJ. And the last thing, of course, is our sample application that's available in the GitHub repository. It has lots of examples of different features, some that I mentioned, some that I didn't mention. You can see like the menu of different options that is provided inside the Litho application. And if you have some question of how to use these or that concept, you may consult with this example to see what is the better way to do something like animation, showing errors in your UI, updating horizontal scrolls. That's it. So a couple of resources to continue investigating with Litho. It's Litho website, of course, with the official documentation. Sample app that I mentioned, your source of truth for different possibilities that framework provides. We are working on Litho code labs that will be available this half, I would say, but I don't promise you anything. But you can see README files, like usual Markdown README files, in our repository as well, and see how you can manage state, how you can use props, how you can use lazy state updates, trigger events, all that stuff. That is something that is available in the code, but not available in the website right now. And if you would like to know more about how Litho manages laying out stuff in the background and what are our threading strategies, I would recommend you to see this talk from my colleague who recently spoke in London about our experiments with Litho threading model. So that's basically it. Thank you very much for attention. I would love to answer your questions.